Hope you all are fine and doing good in chemistry 5070 and 0620. If you have any queries or facing problem in any topic, do write in the comment box. In this lesson, I will begin the new topic, which is about identification of ions. The learning outcomes for this lesson are describe, test to identify the anions, carbonate, CO3 minus 2 by reaction with dilute acid, and then testing for carbon dioxide gas, chloride, Cl negative, bromide, Br negative, and iodide, I negative, by acidifying with dilute nitric acid and then adding aqueous silver nitrate. So in this video, I will talk about the test and results for the anions, carbonate, CO3 minus 2, chloride, Cl minus, bromide, Br minus, and iodide, I minus. The first anion is carbonate, CO3 2 minus. You can even write CO3 minus 2. In the sample solution, first we will add dilute acid like dilute hydrochloric acid. We will see effervescence or fizzing. These are of carbon dioxide gas. Then we'll pass this gas through lime water. Lime water turns milky. So let me write sample solution. Sample solution plus dilute hydrochloric acid. Write the observation. Fizzing. This carbon dioxide gas, CO2 gas. Pass the gas through lime water. Pass the gas through lime water. This is the test. Result. Lime water turns milky. In the next slide, I will show you the end result as well as the reactions taking place here. So this is the end result of this test. You have passed the gas. This is the gas through lime water. This one is lime water. And here it's colorless. Let me write it as colorless. And here it's turning milky. Now I'm writing the reaction. For example, we have calcium carbonate. I'm writing the reaction between calcium carbonate. Sample contains calcium carbonate reacted with hydrochloric acid. What we will get? We will get calcium chloride. For your convenience, I am also balancing the equation. Equation is balanced. We are concerned with this test of this carbon dioxide. This carbon dioxide gas is reacted with lime water. Lime water is calcium hydroxide, CaOH whole twice. Now what we are getting? We are getting calcium carbonate plus water. The equation is balanced. You see, this calcium carbonate is responsible for milkiness. As it is insoluble in water.
Welcome to Chain of Qualified Tutors. Unlock your academic potential with expert tutoring, from secondary school to graduation level. Master math, science, English, and more with personalized one-on-one guidance. Call or WhatsApp for a free demo session. We offer on-site and online tuition.
Now identify the anions: chloride, Cl minus, bromide, Br minus, and iodide, I minus. For testing the presence of chloride, bromide, and iodide ions, we will add nitric acid first to the sample. We'll write sample solution plus nitric acid. Nitric acid is added to destroy any carbonate present. Nitric acid is added to destroy any carbonate present. In the solution. Because this will then interfere with the test of these anions, silver nitrate solution is added then. Silver nitrate solution is added. If chloride ion is present, then it will give white precipitate like this. This one shows chloride ion, this one Cl negative. You see it's white precipitate, there's no color. If bromide ion is there, it should be creamy white precipitate. And if iodide ion is present, it should give yellow precipitate like this. This one is of iodide. Let me write their color. White PPT. Here you'll get creamy white. This one yellow PPT. Yellow PPT for iodide. Now I will show you the original colors of the precipitate obtained. This one is of chloride, Cl negative. You see white precipitate. This one is bromide, creamy white. Iodide, yellow. I will write it again. White PPT. Here you get creamy white. PPT. And here it says construct the chemical and ionic equations for the reactions between silver nitrate and sodium bromide. It's easy to recall the chemical formula of the compounds and precipitation reactions. First, I will write the chemical equation and then ionic equation. The first one is between silver nitrate and sodium bromide. Formula for silver nitrate is AgCl NO3. It's soluble. I will write aqueous. Sodium bromide should be soluble. I will write aqueous again for this one. This is an example of precipitation reaction. The partners will be exchanged. The product will be AgBr, silver bromide, and sodium nitrate. We know that sodium nitrate, all nitrates are soluble, so we'll write aqueous. We'll get the precipitates of bromide, so it should be solid, should exist in the solid state. So I will write ions of the compounds which are aqueous. So it will be like this: Ag plus, I'm not writing aqueous here, NO3 minus, Na plus, Br minus. I have to leave this one like this, AgBr. For your convenience, I will write the aqueous for all these. These are aqueous. The ions which are common or spectator ions are cancelled on both sides. Let me show the spectator ions. This is spectator ion. This is also spectator ion. So these will be cancelled. And the final ionic equation will be like this: Ag plus aqueous, Br minus aqueous, AgBr solid. Now I will write the chemical equation and then ionic equation for this reaction. This is a reaction between silver nitrate and sodium iodide. AgNO3 should be aqueous. Sodium iodide NaI aqueous. AgI solid plus sodium nitrate. Now let's make ionic equation. It is easy. First of all, you have to write ions of the compounds which are aqueous. So it will be Ag plus aqueous, NO3 minus aqueous, Na plus aqueous, I minus aqueous, get AgI solid plus Na plus aqueous, NO3 minus aqueous. Now cancel the common or spectator ions on both sides of the equation. These are the spectator ions, nitrate and sodium. So these will be cancelled. And the final ionic equation will be like this: Ag plus aqueous plus I minus aqueous will get AgI solid. The learning outcomes for this lesson are: describe, test to identify the anions, nitrate NO3 minus by reduction with aluminium foil, and aqueous sodium hydroxide, and then testing for ammonia gas. Sulfate SO4 2 minus by acidifying with dilute nitric acid, then adding aqueous barium nitrate. Sulfide SO3 2 minus by reaction with acidified aqueous potassium magnate 7. In this video, I will talk about the test and results for the anions, nitrate, sulfate, and sulfite. For NO3 ions, NO3 minus ion, we will add dilute sodium hydroxide and little aluminium powder. Sample solution. Plus dilute sodium hydroxide plus aluminium. You can even write foil or powder. A pungent smell gas is produced. A pungent smell gas is produced, which gives the test for ammonia. That is turns moist or damp red litmus paper blue like this. This is moist red litmus paper. And it will turn blue like this. Now, this slide shows the original change in color. You see the color change from pink or red to blue. Pink or red. This one is pink or red, and this will be blue. It's purplish, but we call it blue here. For sulfate ion, add dilute nitric acid and then barium nitrate solution. Sample solution. Plus dilute nitric acid plus barium nitrate solution. Now you have to recall why nitric acid is added here: to destroy any carbonate present. To destroy any carbonate present. White precipitate will be obtained. Here you will get white precipitates. These are of barium sulfate. Barium sulfate. This slide shows the original color of white precipitate obtained for the presence of sulfate ion. White precipitate for barium sulfate. For sulfite ion, warm the sample solution with dilute acid. Sample solution plus warm plus dilute acid. A pungent smell gas is released. A pungent smell gas is released, which turns acidified potassium manganate 7 from purple to colorless. Acidified potassium, manganate, seven, from purple to colorless. This is a solution of potassium, manganate, potassium, manganate. You can write 7 here. It is purple in color. And you see, it turns to colorless. This is colorless, indicating the presence of the sulfide ion in the outcomes for this lesson are: stripe test using aqueous sodium hydroxide and aqueous ammonia to identify the aqueous cations: aluminium Al3 plus, calcium Ca2 plus, and zinc Zn2 plus. Describe test using aqueous sodium hydroxide and aqueous ammonia to identify the aqueous cations: chromium 3, chromium 3 plus, copper 2, copper 2 plus, iron 2, Fe2 plus, and iron 3, Fe3 plus. I will start with the color of the sample solution. When a sample solution is colored, then it must contain transition metal ions. So we will write transition metal ions are present. Transition metal ions are present. So when a sample solution is colorless, then you will write transition metal ions are absent. First, I will talk about the test for colorless sample. Test and result with the aqueous sodium hydroxide will be like this. White precipitate, if this precipitate dissolves in excess of sodium hydroxide, then it contains one of these ions, Zn2 plus or Al3 plus or Al3 plus. If precipitate is soluble in excess of aqueous sodium hydroxide. If the precipitate is insoluble in excess, or you can say it does not dissolve, so you can say it must contain Ca plus 2 or 2 plus. If PPT, you can even write PPT does not dissolve in excess of aqueous sodium hydroxide. Now I will talk about the test and result for the colorless sample, but this time with aqueous ammonia. If white precipitate is soluble, it must contain Zn2 plus. If PPT dissolves in excess of ammonia. And if it does not dissolve, then it must contain Al3 plus or plus 3. If PPT does not dissolve in excess of ammonia. And if there is no reaction or no PPT, you can even see no PPT, no precipitate, then it must contain Ca plus 2. You will see these kind of colors in the test tubes. Right one shows a precipitate which dissolves. This one is the precipitate dissolving in excess of either NaOH or NH3. Now, if white precipitate does not dissolve, then it must show PPT like this: precipitate not dissolving, which does not dissolve in excess of either NaOH or NH3. The tests for colored ions are easy to remember. These tests will be performed when the sample solution is colored. First, I will start with aqueous sodium hydroxide. Green precipitate, it's insoluble in excess. And must contain Fe plus 2 ion. A blue precipitate insoluble in excess. It must contain Cu plus 2 ions. Again, you are getting green or gray-green precipitate, but this time if it is soluble in excess, then it must contain Cr plus 3 ions. Reddish brown precipitate insoluble in excess indicates the presence of Fe plus 3 ions. Test using aqueous ammonia or green precipitate, again insoluble in excess. Fe plus 2 ions. Blue precipitate, but this time it's soluble in excess. And it must be Cu plus 2 ions. Green or gray-green precipitate. You can even write or gray-green. But this time it's insoluble in excess of aqueous ammonia. You must say then it must contain Cr plus 3 ions. Reddish brown precipitate, and it's insoluble in excess. Then it must contain Fe plus 3 ions. So the color of the ions obtained will be like this. For example, if it's green, Fe2 plus, green precipitate like this. And if it's blue precipitate, For Cu2 plus, it will be like this. And if it is of Cr3 plus, then it must be like this. Gray-green precipitate. For Fe2 plus, Fe3 plus, sorry, it will be like this. Here you are getting Fe plus 2. Here you are getting Cu plus 2. Here you are getting Cr plus 3. And the last one is Fe plus 3. Now let's see the original color of the precipitates obtained. The first one is of Cu plus 2. This one is Cu plus 2. The second one is of Cr plus 3. The third one is of Fe plus 3, the reddish brown. And last one on the right side, it's Fe plus 2. You see the difference between Cr plus 3 and Fe2 plus is a difference. In case of Cr plus 3, it's gray green, but in case of Fe plus 2, it's green in color. The last is for ammonium ion. This is the ammonium ion. It neither gives white or white precipitate, which means that if neither white or colored precipitate is obtained in the sample solution, then heat the solution with aqueous sodium hydroxide. A pungent smell gas is produced which turns moist or damp red litmus paper blue like this. You get blue color like this. This is litmus paper. I will write the test. Sample solution does not give white or colored PBT. Then heat the solution. We have already added aqueous sodium hydroxide. We write with NaOH. Heat the solution. Then a pungent smell gas is produced, which turns moist or damp litmus paper blue. Try test using aqueous sodium hydroxide and aqueous ammonia to identify the aqueous cations Al3 plus, calcium, Ca2 plus, and zinc Zn2 plus. Describe test using aqueous sodium hydroxide and aqueous ammonia to identify the aqueous cations chromium 3, Cr3 plus, copper 2, Cu2 plus, iron 2, Fe2 plus, and iron 3, Fe3 plus. Now I'm showing you how you can write the ionic equation between the salt of aluminum and sodium hydroxide. I'm taking aluminum chloride salt for this reaction. You know the formula of aluminum chloride, that will be AlCl3. First, you will write the balanced reaction equation between aluminum chloride and sodium hydroxide. Don't forget the state symbols here, as it will help you in construction of final ionic equation. The equation will be like this. You will get This is an example of double displacement reaction. So you will get what? You will get AlOH whole thrice plus NaOH. So I will write the state symbols here. You are having aqueous. The product is solid, and this is not the product. I will write the product again. AlOH O twice solid plus NaCl aqueous. Look at this equation carefully and count the number of atoms for each element. The best way to do is to make column like this. You can make a column on right side like this for reactants and products. On reactant product side, we have same elements. We have Al, Cl, Na, O, and H. Put a line like this. Count the number of atoms on each side. You'll find this. Al, 1 on both sides of the equation. Or what chlorine is 3 on right reactant side, but 1 on product side. Na is 1 on both sides of the equation. O is 1 on reactant side, but 3 on the product side. Hydrogen 1 on reactant side, 3 on the product side. Both Al and Na are balanced in this equation. Al and Na are balanced, but ClO, O, and H, they are unbalanced. What if you place a 3 before NaCl on product side? Then the equation will become like this. AlCl3 plus, I'm not writing the state symbol as I'm balancing the equation. AlOH whole thrice and NaCl. If we write 3 here, what will happen? We can become like this. Now Na become unbalanced on product side. On reactant side, it become unbalanced. Write 3 here. It's 1 on the reactant side. So what if you will write a 3 before NaOH? In this way, we'll be able to balance the whole equation. Now the whole equation is balanced. If you want, you can count the number of atoms on each side and find they are balanced. Now write the ionic equation for this reaction. You know the rule. You know that this is aqueous. This is also aqueous. This is solid, and this one is aqueous. So, but first of all, you write the ions for aqueous state only. So you get this Al plus 3 aqueous plus 3Cl, not Cl3, minus aqueous plus 3Na positive aqueous plus 3OH minus aqueous product side. Leave it like this as it is in the solid state. AlOH whole 3 solid, and we have 3Na plus aqueous, 3Cl minus aqueous. So cancel out the common or spectator ions on both sides of the equation. You know these are the spectator ions. These are common. Na plus, Cl minus. So in the end, you will get this. This will be the final equation. Al plus 3 aqueous plus 3OH minus aqueous gives AlOH whole thrice solid. This is your final equation. So here's the question for you. I will solve the first one for you. Construct the chemical and ionic equation for the reaction between sodium hydroxide and copper 2 chloride, sodium hydroxide and iron 3 chloride. First, you will write the balanced reaction equation between sodium hydroxide and copper 2 chloride. Don't forget the state symbols. Sodium hydroxide is NaOH, aqueous. CuCl2, what you will get? Cu is carrying +2 charge, Cl belongs to group 7. It must carry -1. Ignore their charges, these become subscripts. Subscripts will be exchanged and you will get CuCl2 plus CuCl2 aqueous. The product will be CuOH whole twice solid plus NaCl. The equation is not balanced. The same way you can do this by making a column on right hand side of the page for reactant and product. We have the elements, atoms of the elements NaOH, Cu, Cl. Count the number of atoms on each side. Na, 1 on both sides. O, 1 on reactant side, but 2 on product side. Hydrogen, 1 on reactant side, 2 on product side. Cu, 1 on both sides of the equation. Cl, 1 on the reactant side and 1 on the product side. Now, if you look at this equation, these all are balanced. Na is balanced, Cu is balanced, Cl is balanced. But O and H, they are unbalanced. Both of these are unbalanced. So you need to balance these. So what if I'll put 2 before NaOH in order to balance O, oxygen and hydrogen on the product side? The equation will become like this: 2NaOH aqueous plus CuCl2 aqueous gives CuOH whole twice plus NaCl aqueous. Now sodium become unbalanced on the product side. These two will be balanced now. So on 2 on the reactant side, and sodium will be 2, so it will be unbalanced on the product side. So what if I'll put 2 before NaCl on the product side? The equation become like this: NaOH, 2NaOH aqueous plus CuCl2 aqueous gives CuOH whole twice solid plus 2NaCl aqueous. If you count the number of atoms, each atoms are balanced in this. Now write the ionic equation for this one. Remember, do not open the compound which is in the solid state. So you'll get this 2Na plus aqueous plus 2OH negative aqueous plus Cu plus 2 aqueous plus 2Cl negative, not Cl2, aqueous. It gives 2Na plus aqueous plus 2Cl negative aqueous, and the other product is CuOH whole twice solid. Cancel out the spectator ions. In this we are having Na and Cl negative. So the final ion equation will be like this: 2OH minus aqueous plus Cu plus 2 aqueous, and the product will be CuCl2 solid. This will be the final ionic equation for this one. I want you to try this by yourselves. The learning outcome for this video lesson is: describe, test to identify the gases ammonia, NH3 using damp red litmus paper, carbon dioxide, CO2 using lime water, chlorine, Cl2 using damp litmus paper, hydrogen, H2 using a lighted splint, oxygen, O2 using a glowing splint, sulfur dioxide, SO2 using acidified aqueous potassium magnate 7. I will share tests and observations for all the gases mentioned in the SLO. I will also talk about their action on litmus paper. So let's start testing gases. So first gas is ammonia, NH3. The test and observation. It's a pungent smell gas, and when a glass rod dipped in hydrochloric acid is brought close to this gas, white dense fume will be produced. Pungent smell. When a glass rod dipped in HCl is brought close to this gas, white dense fumes will be produced. Action on litmus paper. It turns moist, damp, red litmus to blue because the gas is basic or alkaline in water. That this produces OH negative ion in water. Carbon dioxide. When bubbled through lime water turns solution milky, extinguishes burning splint or matchstick. When bubbled through lime water turns solution milky, extinguishes burning splint or matchstick. That's why it's used in fire extinguisher. It's an acidic gas, which means it turns moist, damp, blue litmus paper to red. Turns moist or damp blue paper red. Chlorine, it's a yellowish green or pale green gas. Yellowish green or pale green gas. Gas is also acidic in nature, which initially turns blue litmus paper red, then bleaches damp litmus paper. Bleaches damp litmus paper. Hydrogen gas, H2. When a burning splinter is brought near to the gas, pop sound will be produced. So right, pops up or produces squeaky sound with the burning splint. It's colorless. It is colorless and explosive gas. There is no action on litmus paper. Oxygen gas O2 relights or rekindle a glowing splinter or matchstick. Relights or rekindle the glowing splinter. Again, it has no action on the litmus paper. Last one is sulfur dioxide. It's also a pungent smell gas, but it turns acidified aqueous potassium magnate 7 from purple to colorless. Pungent smell gas which turns acidified aqueous potassium magnate 7 from purple to colorless. From purple to colorless. It's an acidic oxide, so it turns moist, damp blue litmus paper to red due to the production of H positive ion in water. Now I will show you the change in color of litmus for ammonia, carbon dioxide, chlorine, and sulfur dioxide. For ammonia, you will see the final blue color like this. This is the final blue color, which will like purplish. When moist or damp red litmus paper is brought near to this pungent smell gas due to alkaline or basic nature of ammonia in water. A carbon dioxide gas, carbon dioxide is an acidic oxide. Acidic oxide. And we know that with the exception of water, carbon monoxide and nitrogen monoxide, all the other non-metal oxides act as acidic oxide. Therefore, it turns moist blue litmus paper red. It's red color you'll obtain due to acidic nature of the gas in water. Chlorine gas is not basic or alkaline gas, but acidic. So when moist blue litmus paper is brought near to the gas, it will turn it red and then bleaches it like this. Acidic, not basic. So this one is bleach. Due to Cl2 gas. Sulfur dioxide gas is an acidic oxide just like CO2, therefore it will turn moist or damp blue litmus paper red due to the production of H positive ion in the water. Acidic oxide. So this is due to acidic nature of the gas in water. Now I will talk about the flame test. This one is a short one. You just need to remember the flame color for some metal ions in the SLO. The learning outcome is describe the use of a flame test to identify the cations, lithium Li positive, sodium Na positive, potassium K positive, calcium Ca positive, Ca2 positive, barium Ba2 positive, copper 2 Cu 2 plus. So lithium gives a red color in flame. So you write red. Sodium or Na positive ion gives yellow color in the flame. So you write yellow here. Potassium gives lilac color. Lilac color is purplish. Calcium Ca2 plus gives orange red color. Barium gives green color, pale green, in fact, pale green. Cu2 plus, as you all know, it gives blue-green color. With flame, it will give blue-green color. So you have a color like this, blue, green.